and is waiting at a stoplight. When it finally turns green, he accelerates from rest at a rate of 6.00 meters per second squared for a time of 4.1 seconds. Determine the displacement of Ben's car during this time period. Well, once again, if we take a look at our cars, Ben is sitting at a stoplight here, and then finally the light turns green. So we can say something about Ben's velocity here. It starts at 0 meters per second, but that's a velocity initial. Later on in the question, it tells us that Ben accelerates in the x-axis at 6.00 meters per second squared. And there's only one more bit of information that the question gives us, and that is time equals 4.10 seconds. Given this information, we can figure out displacement. So the first thing we know is velocity initial equals 0 meters per second. Acceleration in the x equals 6.00 meters per second squared, and that time is 4.10 seconds. The thing that I want to know is how far he traveled, so that's a displacement, in this case in the x-axis. And that's going to be question mark, but that's going to be in meters. So the equation we're going to use is displacement equals velocity initial times time plus 0.5 times the quantity acceleration times time squared. So I'm going to replace numbers for letters. D equals 0 times 4.10 plus 0.5 times acceleration, which is 6.00 times time squared, when time is 4.10 squared. Now any number times 0 cancels, so this all blows up, leaving us with D equal to 0.5 times, and if I multiply this together in my calculator, I get 100.86. And then when I do that math, I get distance equals 50.43. And now it's time to significant figures, so let's see. That doesn't count as significant figures. This has 3 sig figs. This has 3 sig figs. My answer is going to have 3 sig figs. So I can go 50.4 meters.